Hello viewers, you are welcome to my channel. This is Royal Learning Channel. If you are new here, kindly click on the subscribe button, share, like and leave comments. In this video, we are going to be talking about qualitative analysis, which is also known as SWOT analysis for 2025 WAEC Chemistry Practical. In my last video, we have discussed about the quantitative analysis. Then we solved likely questions on quantitative analysis. So we are going to talk about the SWOT analysis. So for that day, you'll be provided with sample label C. You'll be provided with sample label Cn. Then your Cn is a mixture of glucose. Your Cn is a mixture of glucose and copper sulfate. Your Cn is a mixture of glucose and copper sulfate in ratio 1:1. In ratio 1:1. So in ratio 1:1 means that if you take 1 spatula of glucose, you are going to take 1 spatula of what? Of copper sulfate. Then you mix the two together. 1:1. If you weigh 1 gram of glucose, you weigh 1 gram of copper sulfate. Then you mix the two salts together. So this here sample consists of what? An organic salt. Glucose is organic, while copper sulfate is what? Is an inorganic salt. But before we discuss about our sample for this year, I want to briefly explain general chemical test on cations, anions, identification of gases, and flame test, so that you can have an idea on how to answer questions on qualitative analysis without carrying out the experiment. So let's talk about the general test. Let's talk about the general test. So let's talk about the cations. The cations, we have calcium, we have lead. Don't forget that the cations are the positive ions. They are the positive ions. So we have calcium, we have lead, we have aluminium, we have zinc, then we have copper, then we have iron 2, then we have iron 3. Iron 3. So we always use aqueous sodium hydroxide, and aqueous ammonia to differentiate between the following cations. We always use aqueous sodium hydroxide and aqueous ammonia to test for cations. So what will be the effect of sodium hydroxide, aqueous sodium hydroxide, on calcium and lead? Let's take calcium and lead together. Calcium and lead will give you white precipitate on addition of what? Of aqueous sodium hydroxide. So when aqueous sodium hydroxide is added to a calcium containing compound or lead compound, what you are going to have is white precipitate. So for lead, white precipitate, the precipitate will dissolve when you add excess sodium hydroxide. If it is lead, the precipitate will dissolve when you add excess sodium hydroxide. But calcium will be insoluble in excess sodium what? In excess aqueous sodium hydroxide. Then aluminium and zinc. Aluminium and zinc will give you white gelatinous precipitate. Aluminium and zinc will give you white gelatinous precipitate. Then the two of them will be soluble in what? In excess sodium hydroxide. Aluminium will give you white gelatinous precipitate when drops of aqueous sodium hydroxide is added to them. Then when you add aqueous sodium hydroxide in excess, they will dissolve in excess. So the precipitate will dissolve in excess. Then copper. When aqueous sodium hydroxide is added to copper, you are going to have what? Blue gelatinous precipitate. Pale blue or light blue gelatinous precipitate will be formed in drops. Then in excess, the precipitate will remain insoluble in excess. For iron 2, when dilute sodium hydroxide is added to iron 2, you are going to have dirty green gelatinous precipitate in drops and in excess. That is when you add this aqueous sodium hydroxide in drops and in excess, the dirty green gelatinous precipitate will remain insoluble. Then iron 3 will give you reddish brown gelatinous precipitate, both in drops and in excess, so it shows that from this test now, only copper is blue. Only copper will give us blue gelatinous precipitate with sodium hydroxide. Then only iron 2 will give us dirty green gelatinous precipitate with sodium hydroxide. Only iron 3 will give us reddish brown gelatinous precipitate with sodium hydroxide. So calcium and lead will give us white precipitate in drops, but in excess. Lead will dissolve in excess, while calcium remain insoluble in excess. Then for zinc and aluminium, the two of them will give us white gelatinous precipitate, both in what? In drops and what? In excess. Both in drops and in excess. So aluminium will be soluble in drops and in excess. Then zinc will also be what? Soluble in excess. It will be soluble in excess. Then we always use ammonia, aqueous ammonia, for confirmatory test. Aqueous ammonia, or you call it dilute ammonia, for confirmatory test. Then don't forget that the two will give you white precipitate. Then when you add aqueous ammonia to lead, if it is lead will remain insoluble in excess aqueous ammonia. Lead will remain insoluble in excess aqueous ammonia. So when you add aqueous ammonia to calcium ion, there will be no feasible reaction, no precipitate if it is calcium. But when you add ammonia to lead, the precipitate, the white precipitate, will remain insoluble in excess ammonia. Now, let's take aluminium and zinc. So when you add ammonia, aqueous ammonia, to aluminium will remain insoluble. It will not dissolve. It will remain insoluble in what? In aqueous ammonia, while zinc will dissolve. That is, zinc will be soluble in aqueous ammonia. So when you add ammonia, aqueous ammonia to copper, in drops, it will give you pale blue gelatinous precipitate. When you add it in excess, when you add ammonia in excess, so that pale blue gelatinous will dissolve in excess to give you a deep blue solution. It will dissolve to give you a deep blue solution. So let's look at iron. Don't forget that iron will give us what? Dirty green. So when you add ammonia, it will still give you what? Dirty green. The dirty green will remain insoluble in drops and in excess ammonia, aqueous ammonia. So likewise, iron 3 will give you reddish brown gelatinous precipitate, which will remain insoluble in excess what? In excess aqueous ammonia. So let's briefly talk about the anions. So what are anions? They are the positive, they are the negative ions. Anions are the negative ions. So I'm going to talk about common examples of anions. We have CO32 minus, then we have SO32 minus, we have SO4 2 minus, we have Cl minus, then I minus. This one and this one are under the same category. They are under the same category. So let's talk about these 4 common examples of anions. Then we don't always use sodium hydroxide to test for anions. So the common examples of compound or reagents that we always use to test for anions are silver nitrate, aqueous silver nitrate, then barium chloride, then barium triazonitrate, So these are the common examples. Of reagents that we always use to test for the anions, the negative ions. Then this silver nitrate is always for chlorine. Then when you add silver nitrate to chlorine compound, to a compound of chlorine, white precipitate will be formed. When you add silver nitrate to a compound of chlorine, white precipitate will be formed. Then the precipitate will dissolve in what? In dilute acid. In dilute acid, especially HCl and HNO3. And don't forget that HNO3 is a strong oxidizing agent. So while barium chloride and barium nitrate are always used to test for these three cations, so we always use barium chloride and barium nitrate to test for these three cations. Now, how can we differentiate them? When you add barium chloride solution, that is aqueous barium chloride, to any of the compound containing these cations, white precipitate will be formed. Then what will now single out the particular anion that we are looking for is addition of what? Of acid. Is addition of an acid. So this acid now, after addition of barium chloride, don't forget that the three of them will give you white precipitate when you add aqueous barium chloride. Any of a compound containing this ion will give you white precipitate on addition of what? Of barium chloride or barium nitrate. But how can we differentiate? How can we single out the particular anion that are present? Now, after addition of barium chloride, then you add HCl or you add HNO3. Either HCl or HNO3. Then if it is CO3, on addition of HCl, there will be effervescence. Of colorless and odorless gas. Just as if you open the bottle of soft drink, it will start foaming like that. That is effervescence. So there will be effervescence of colorless and odorless gas. Then when you have colorless and odorless gas, now test that gas with lime water. If it is CO3, it will turn lime water to blue. It will turn lime water milky. Sorry. If it is CO3, it will turn lime water milky. Then, if it is SO3, the white precipitate. Now, let me come back to this one again. After addition of barium chloride, they will give you white precipitate. On addition of hydrochloric acid, if it is CO3, the precipitate will dissolve. The white precipitate will dissolve to give you effervescence of that colorless and odorless gas, which turns lime water milky. Then, if it is SO32 minus, on addition of HCl, the white precipitate will dissolve. And release a colorless gas with pungent smell. So what is the name of that gas? So the gas is SO2. It will release a colorless gas with pungent smell. Then you now test this gas. How can we test for SO2 gas? That's sulfur 4 oxide gas. Then you test when this gas passes through the purple color of KMNO4, potassium permanganate. It will decolorize the purple color of potassium permanganate. Or you add K2Cr2O7, that's potassium dichromate. On addition of potassium dichromate, if it is SO2 gas, the orange color, the normal color of potassium dichromate is orange. The orange color of potassium dichromate will change to green. Then, To confirm again, I said you can also use KMnO4. The purple color of KMnO4 will turn to colorless to confirm this SO2 gas. Now, if it is SO4, on addition of hydrochloric acid, the white precipitate will remain insoluble. The white precipitate will remain insoluble what? Insoluble in hydrochloric acid. That is how to differentiate between SO3 and SO4. When you add HCl, the precipitate will dissolve. The white precipitate will dissolve to give what? SO2 gas. Then when you add HCl, if it is SO4, the precipitate will remain insoluble. The precipitate will remain insoluble. Then no gas will be evolved. No gas will be evolved. Then let's talk about flame test. Let's talk about flame test. So let's take, for example, calcium. When calcium is exposed to direct blue flame, it will give you a brick red flame. Brick red flame will be produced. Then if it is sodium ion, sodium will give you yellow flame when it is exposed to direct blue flame. Copper will give you green. When copper containing compound is exposed to direct blue flame, it will give you green flame. Then if it is lead will give you blue flame. And so on and so forth. Then let's briefly talk about gases, identification of gases. Let's talk about identification of gases. Oxygen gas, hydrogen gas, carbon dioxide gas, SO2 gas, then NO2 gas. Then NO2 is always from NO3 minus. Then SO2 from either SO3 2 minus or SO4 2 minus. Then CO2 from either CO3 2 minus or HCO3 minus. Then oxygen gas. How can we test for oxygen gas? Oxygen gas is colorless and odorless. But oxygen gas will rekindle a glowing splint. Then hydrogen gas is colorless and odorless. It will give you what? A pulp sound with a lighted splint. Pooh, with a lighted splint. Then CO2 gas, carbon dioxide gas, is colorless and odorless. It turns lime water milky. Then SO2 gas is a colorless gas with pungent smell or irritating smell. So it turns the purple color of KMnO4 to colorless, or it turns the orange color of potassium dichromate to orange. Then NO2 is a brown gas. It's brownish. So the gas is brownish. Then it turns the starch iodide paper to blue-black. It will turn starch iodide paper to blue-black. So let's come back to our sample for this year. Let's come back to our sample for this year. So your sample will be labeled CN. So your CN is a mixture of glucose. And copper sulfate. So what should we be expecting on these two samples? What should we be expecting? Then we are going to mix one spatula. If you are taking one spatula of glucose, you take one spatula of copper sulfate. If you weigh 1 gram of glucose, you have to weigh 1 gram of what? Of copper sulfate, and mix the two together. Then what should we be expecting on copper sulfate? So copper sulfate, which is CuSO4, will decompose to copper ion, and SO4 ion. So it shows that we should be expecting tests on what? On copper, and we should be expecting what? Chemical tests on sulfate. So we should be expecting chemical tests on sulfate and copper. Then another one is glucose. Then glucose is an organic compound. It is an organic compound. Then don't forget that glucose carries the functional group of alkanal. It carries the functional group of alkanal. It carries the functional group of alkanal, that is CHO. It carries the functional group of alkanal, which is CHO. So we are going to use chemical test. So glucose is a reducing sugar. Glucose is a reducing sugar. So we can use chemical test for alkanal, for what? For glucose. Then what are the likely chemical tests for glucose? Addition of what? Of Ferlin solution. Addition of Ferlin solution. Then addition of Benedict solution. Addition of Benedict solution. Then addition of toluene reagents. You can use toluene reagents to test for reducing sugar, e.g. glucose. You can use Ferlin solution or Benedict solution to test for reducing sugar, like glucose. Then don't forget that I told you that we always use sodium hydroxide, aqueous sodium hydroxide, and ammonia. We always use aqueous sodium hydroxide. Let's take copper first. So we can use what? Aqueous sodium hydroxide, and what? And ammonia, and aqueous ammonia, to test for what? To test for copper. Then we can also use potassium ferrocyanide. We can use potassium ferrocyanide, that is KFeCN6. Aqueous potassium ferrocyanide to test for copper. So we are going to use these three samples to test for copper. Then let's look at SO42 minus. Then don't forget that SO42 minus is an anion. Is an anion. I just explained now that we can use what? Barium chloride. Aqueous barium chloride. Aqueous barium chloride, or aqueous barium triazonitrate. Aqueous barium triazonitrate to test for anion. To test for anion. So for glucose, we are going to use Ferlin solution. We are going to use Ferlin solution. That is, the Ferlin solution means Ferlin solution A and B. Then we can also use Benedict solution. Benedict solution. Then we can use toluene reagents. Toluene's reagents. Toluene's reagent is ammoniacal solution of silver nitrate. So we can use toluene reagents to test for glucose. Then we can also use ammonia. We can use ammonia. Then when the solution is what? Is heated. Ammonia plus heat. Ammonia plus heat. So those are the chemical tests that we are going to carry out on our sample C. The sample C is a mixture of glucose and copper sulfate. So copper sulfate is light blue. The color of copper sulfate is light blue, while glucose is white. Glucose is white. So when glucose dissolves in water, it will give you colorless solution. When glucose dissolves in water, it will give you colorless solution like color of water. Then when copper sulfate dissolve in water, you are going to have light blue solution. So the two of them are soluble salts. They are soluble compounds. So they will dissolve in water without any precipitate. So when we now mix the two together, when we mix the two together, this glucose, which is colorless, will not alter the color of copper sulfate. It will not alter the color of copper sulfate when you add what? The colorless solution of what? Of glucose to the light blue solution of copper. So this glucose will not alter the color of what? Of copper sulfate. So which means that addition of glucose and copper sulfate in water will still give you light blue solution. So let's work on this predicted question. Let's work on these predicted questions. So our question says that C is a mixture of organic and inorganic compounds. C is a mixture of organic and inorganic compounds. The one organic is glucose, while the one inorganic is what? Is copper sulfate. Is copper sulfate. So record your observations and inference. Identify any gases involved. Then how do we record our results on qualitative analysis? How do we record our results on qualitative analysis? So you are going to prepare a table. Then the table will be divided into three columns. The table will be divided into three columns. The first one will be for test. The second one will be for observation, while the third one will be for inference. So let's do that. So test, observation, and inference. Test, observation, and inference. So let's continue with this predicted question. Put C into a test tube. Put C into a test tube. Then what is our C? A mixture of glucose and copper sulfate. Put C into a test tube and add about 10 ml of distilled water and shake well. So for A now, let's answer that question. A, you are going to write A. Put C, that is a sample C plus put C in a test tube and add what? About 10 ml of distilled water. So you don't need to record that distilled water here. But when you are carrying out the experiment, you are going to add what? That 10 ml of distilled water. So just say plus what? Plus distilled water. Plus distilled water. Then plus distilled water and shake well. Then you shake the what? The mixture. You are going to shake the mixture. Then don't forget that, like I said, that glucose will dissolve in water, which is colorless. Then copper will give you light blue. But this glucose will not alter the color of what? Of copper. The two will dissolve in water. The two of them will dissolve in water. So automatically, what will be our observation? Light blue solution. So we are going to say C dissolved. C dissolved to form a light blue solution. C dissolved to form a light blue solution. Then what is our inference? We always use distilled water to test for solubility. We don't use distilled water to test for cations, anions, flame test, or for any identification of gas. We always use distilled water to test for solubility of any sample. So what will be our inference now? C dissolved to form a light blue solution. So it shows that C is a mixture of what? Of soluble and insoluble what? Compound. Because according to our question, they said that C is a mixture of organic and inorganic compounds. So we are going to say that C is a mixture. C is a mixture of soluble compound. But if it is not stated, in your question that C is a mixture, maybe your question says that C is what? C is a mixture of two compounds. So you don't need to say that C is a mixture of what? Of organic and inorganic compound. So for your inference now, C is a mixture of what? Of soluble compound. Simple. Then let's continue. Test the resulting solution. Test the resulting solution with litmus paper. When they say litmus, they are still referring to what? Litmus paper. So test the resulting solution with litmus paper. Now let's come back to this sample now. Let's come back to our sample. Now, glucose solution is neutral. Glucose solution will be neutral to litmus. But copper, we have copper here, and at the same time we have what? We have sulfate. That's SO4. So SO4 is what? Is acidic. SO4 is acidic. Then an acidic solution will turn what? Blue litmus paper to red. Acid turns blue litmus paper to red. So it shows that our solution consists of what? SO4, an acidic solution. So what will be the effect of litmus paper on this acidic solution? So we are going to say that plus another line. This is one line. Then you now go to another line. Plus litmus paper. Plus litmus paper. So what is the effect of the solution on the litmus paper? It turned or blue litmus paper turned red. Blue litmus paper turned red. So it shows that the solution is what? Is acidic. It shows that that solution is acidic. So what will be your inference for this second step? What will be your inference? So solution is acidic. Solution is acidic. So you have answered A. Now let's move to Roman figure 1. Roman figure 1. To the first portion. A Roman figure 1. To the first portion. So to the first portion, add dilute sodium hydroxide in drops. Add dilute sodium hydroxide in drops. Then you are going to write plus NaOH aqueous in drops. So you record your observation and your inference for in drops. So what will happen in drops? Don't forget that we are testing for copper. Then when sodium hydroxide is added to what? Copper ion, a pale blue or light blue gelatinous precipitate is formed. Then anything blue is what? Is copper. So under our inference now, copper ion present. Then followed by what? In excess. So we are going to add what? Aqueous sodium hydroxide in excess. Then you move to another line. Then plus in excess. Then what will be your observation in excess? Don't forget that both in drops and in excess, the light blue gelatinous precipitate will remain what? Insoluble. So under excess now, so you are going to write the precipitate The precipitate remain what? Insoluble. The precipitate remain insoluble. So it's still what? Copper. Our inference is still copper. Then Roman figure 2. Let's move to Roman figure 2. Let's move to Roman figure 2. Roman figure 2. So Roman figure 2 says that to the second portion, add aqueous ammonia in drops. To the second portion, so to second portion plus what? Aqueous ammonia plus aqueous ammonia. Don't forget to put aqueous or dilute plus aqueous ammonia in what? In drops. In drops. So what will happen when you add what? Ammonia to a copper containing compound in drops. In drops. So you are going to have what? A pale blue gelatinous precipitate. Pale blue gelatinous precipitate is formed. So what is our inference for that? It's still copper. Copper 2 ion present. Copper 2 ion present. Then in drops, ammonia in drops. Then in excess, then you go to another line, you write plus in excess. Plus in excess. So what will happen in excess? The pale blue gelatinous precipitate will dissolve in excess to form a deep blue solution. So the precipitate dissolved in excess to form a deep blue solution. A deep blue solution. To form a deep blue solution. So here now, we can say that copper ion is confirmed. Copper ion is confirmed. Then, another question on this, please, I want to add something to this Roman figure 1. To Roman figure 1, you may be asked to what? To eat your solution plus eat. If they ask you to eat this solution, what you are going to have is the light blue gelatinous precipitate will turn black when the solution is heated. So please, to the Roman figure 1, let's add it. When you eat what? The mixture of what? Our solution C and sodium hydroxide. You are going to have what? Black. The blue gelatinous precipitate turn black. It turns black. It turns black. So copper is still present. Copper ion present. Copper ion present. Now, for this addition of ammonia, we can also use aqueous ammonia to confirm the presence of reducing sugar. We can use aqueous ammonia to confirm the presence of what? Of reducing sugar. Then in our solution C, there is glucose. So which is what? Is a reducing sugar. So when ammonia is added to what? A solution of reducing sugar, then when that solution is now heated, it will give us a brown precipitate. So after this, they might ask you to what? To heat the solution plus heat. If they ask you to heat the solution that you have added this ammonia to, what you want to test for is what? Is reducing sugar. So what will be your observation to that? When this solution, Roman figure 2, is what? Is heated. So you are going to have what? Brown precipitate. PPT means precipitate is formed. Please don't write PPT. Brown precipitate is formed. Brown precipitate is formed. which turns red when strongly heated? Which turned red when strongly heated? Which turns red when strongly heated? There's no more space for that. Which turns red when strongly heated? So what would be our inference? What would be our inference for this last statement? Reducing sugar is present. Reducing sugar is present. Reducing sugar is present. So it shows that when a glucose solution containing compound is added to ammonia and the mixture is heated, a brown precipitate will be formed. But when the solution is strongly heated, you are going to have what? Red precipitate. Red precipitate. So what will be your inference? Reducing sugar is present. Reducing sugar is present. So let's move to Roman figure 3. Let's move to Roman figure 3. Now, Roman figure 3. Roman figure 3 says that to the third portion, add 2 centimeter cube of potassium ferrocyanide to the third portion. So Roman figure 3. To the third portion plus aqueous what? Aqueous solution of potassium ferrocyanide, which is Fe(CN6) aqueous. So what would be our observation when our solution is added to potassium ferrocyanide? So when they add potassium ferrocyanide to a compound, they want to test for copper. So we are going to use that potassium ferrocyanide to test for copper. So our observation will be brown precipitate. Brown precipitate is formed. So brown precipitate is formed. So copper 2 plus is suspected. Copper 2 plus is suspected. Copper 2 plus is suspected. Then Roman figure 4. Roman figure 4. So Roman figure 4 says that to the fourth portion, add what? About 2 centimeter cube of barium chloride. So you are not going to say to the fourth portion plus barium chloride aqueous, from aqueous barium chloride. Don't forget that we always use barium chloride to test for anions. We always use barium chloride to test for anions. So what are those anions? They are SO4 2 minus, SO3 2 minus, and CO3 2 minus. So addition of barium chloride to any of these anion will give us what? White precipitate. So therefore, our observation is what? White precipitate. Please don't write precipitate in exam. Is PPT means precipitate. Don't write precipitate. Write it fully. White precipitate is what? Is formed. White precipitate is formed. So which anions are we testing for? They are SO4 2 minus, SO3 2 minus, or CO3 2 minus is what? Is present. Because we don't know the particular what? We don't know the particular anion that present, or an addition of what? Of barium chloride. So which one will now single out what we are looking for? So let's read further. So after addition of barium chloride, then add dilute HCl. Add dilute HCl. So the next line you are going to write plus dilute HCl. Plus dilute HCl. Don't forget, if it is CO3, there will be effervescence of colorless and odorless gas. If it is CO3, there will be effervescence of colorless and odorless gas, and the white precipitate will dissolve if it is CO3. Then if it is SO2 minus, the precipitate will dissolve with effervescence of colorless gas with pungent smell, which is SO2. But if it is SO4, the precipitate will remain insoluble in dilute HCl. The precipitate will remain insoluble in dilute HCl. Then our sample C consists of copper and SO4. So the only anion in our sample is SO4. So therefore, what will be our inference when dilute HCl is added? Don't forget that this one will not dissolve in what? In excess HCl. So we are now going to say that our next answer will be the precipitate insoluble in dilute what? HCl. So we are using this one to test for what? It will single out this SO4. So therefore, SO4 2 minus is what? Is present. SO4 2 minus is present. Then Roman figure 4. Roman figure 4. Roman figure 4. Then Roman figure 4 says that to the fifth portion, add what? 2 centimeter cube of Ferlin solution or Benedict solution. Add 2 centimeter cube of Ferlin solution or Benedict solution. So Roman figure 5. So to the fifth portion plus Ferlin solution, or you write Ferlin solution A and B. So when you add Ferlin solution to a glucose containing compound, then glucose is a reducing agent. So what are we going to have? Our observation will be what? Brick red precipitate. Brick red precipitate. Then plus heat. On heating or on warming, they will ask you to warm. On warming or on heating, so the brick red precipitate is formed. Brick red precipitate is formed. So what are we testing for? We use Ferlin solution to test for what? For reducing sugar. So therefore, our inference will be what? Reducing sugar is present. Reducing sugar is present. So e.g. glucose. So the same thing with Benedict solution. If you add Benedict solution, it will still give you what? Brick red precipitate. Brick red precipitate of copper 1 oxide will be formed. But you don't need to write copper 1 oxide. So brick red precipitate of copper 1 oxide will be formed on addition of what? Of either Ferlin solution or Benedict. So another one, you might be asked to test your solution C with dilute HCl and warm, or with triazonitrate 5 acid. So what will happen when you add dilute HCl to your solution C and 1? It will have effect on copper sulfate. It will react on copper sulfate, but it will not react until the solution is heated. That is when you add dilute HCl. If you add ordinary dilute HCl to your copper sulfate solution, it will not react. It will still remain what? Light blue solution, but on heating, it will facilitate. So it will facilitate the chemical reaction in order to release what? SO2 gas, and you are going to have greenish what? Greenish precipitate will be formed. So let's take that solution C. Let's just say solution C. Solution C plus dilute HCl, plus heat, So greenish yellow precipitate. Greenish yellow precipitate is formed. Then addition of dilute HCl on warming or heating will facilitate the chemical reaction in order to release SO2 gas. So a colorless gas with pungent smell evolved. Then how can we test for that colorless gas, which is SO2? How can we test for that colorless gas with pungent smell? So the SO2, you use what? Either KMnO4, the purple color of KMnO4. So addition of purple color of KMnO4 and SO2 gas will decolorize that purple color. So you can say which decolorizes the purple color of what? Of KMnO4. Or you can use K2Cr2O7, that is potassium dichromate. If you use potassium dichromate, the orange color of, you say which turns the orange color of potassium dichromate to green. But if it is KMnO4, which decolorizes the purple color of KMnO4. So what will be our inference for the first statement? Green yellow precipitate is formed. So copper is present. Then for the purple color of KMnO4 and the gas evolved. So the gas evolved is what? SO2. SO2 from SO3 2 minus or SO4 2 minus. So the gas is SO2 from SO3 2 minus or SO4 2 minus. So another one is reaction between solution C. Reaction between solution C and dilute triazonitrate 5 acid, then plus heat. So once dilute triazonitrate 5 acid is added to solution C, it will act on the copper sulfate. Present in that solution. So what will be our observation? White residue is deposited. So there will be what? Evaporations of NO2 from what? From NO3. There will be evaporations of NO2 gas, that is nitrogen 4 oxide. There will be evaporations of nitrogen 4 oxide from NO3, from this HNO3. So with evaporations of NO2 is brownish gas. brown gas with pungent smell involved. So NO2 is brownish, is brown gas with pungent smell involved. Then how can we test for NO2 gas? How can we test for NO2 gas? So we use starch iodide paper. So you now say that which turned starch iodide paper, blue black. So which turns starch iodide paper blue black. So for the gas involved, so the gas is what? Is NO2 from what? From NO3 to NO3 minus. The gas is NO2 from NO3 minus. So for the what? White residue that is deposited. For white residue that is deposited, that is copper. Copper 2 ion is present. Copper 2 ion. So we've come to the end of this class. Keep on listening, keep on watching, and keep on learning. See you in my next video. Bye.